2015 Physics Paper 1, Part A, Section 1, Multiple Choice, Question 10. 2-point charges are separated by a certain distance. We'll call that distance R, and experience a force of repulsion F. Let's highlight the F. If one charge is doubled in magnitude, while the distance between them is increased by a factor of 4, what is the new force between them? Let's establish the first situation. Now we do our riddles, we've read the question, we've identified, so let's draw a diagram. We start off here with 2-point charges separated by a certain distance. We'll call that separation from the center of this charge to the center of that charge, the radius R, and they experience a force of repulsion, so let's just say that they are both positive charges. The force of repulsion is K Q1 Q2 on R squared. We'll call this charge Q1, this particular charge Q2. So there's our original situation, so I'll call it F1. Now, one of the charges is doubled, so let's make this charge here 2 times Q1, while the in magnitude, while the distance between them is increased by a factor of 4. The distance between them is increased by a factor of 4. So that means this separation is now 4 times R. Now this diagram won't be to scale because we've gone from a distance R to a distance 4 times R. So therefore, to multiply out to work out what our repulsive force will be, we use the same formula, Q K times Q1 times Q2 on R squared. Now this is charge Q1, this is charge Q2. Now we know, for example, that Q1 in this particular case is actually double that in this case. So K remains the same. We have 2 times Q1 for our first charge. Our second charge is unchanged, and our separation is 4 times R. So our formula becomes K times 2Q1 times Q2. Now if we were to multiply that out, it's 2 times K Q1 over Q2, and to square the bottom is 16R squared, like so. Now in this particular case then, 2 over 16 can be reduced to 1 over 8, and KQ1 Q2 on R squared is our original F1. So therefore what actually happens in this particular circumstance here is when you double one charge, you double the force, but when you quadruple the separation, you reduce the force to 1/16, and the net of multiplying by 2 and dividing by 16 is reducing the overall repulsive force by a factor of 8. So the correct answer is D.